So, hello everyone, good evening. Just let's wait for 2 more minutes so that if anyone will join, then I will admit that person. So, just wait for 2 minutes and then we'll start. So, hello, good evening. So, welcome to the first problem solving session for the course Municipal Solid Waste Management. So, I think this course is a 12-week course. So after, I think the course will end in the mid of the October, and after that there will be a written exam for getting this from giving that exam, you all will get certificate. So I think there are three TAs for this course, and I think my session is on every Saturday. Earlier it was on Sunday, but it was clashing, so it got shifted to every Saturday. It will be from 6 to 8 p.m. And if there will be any changes, then it will be intimated to all of you through mail. So this is the first problem solving session. So every week, what we will do, we will discuss what was covered in the lecture part, and then we will discuss about the previous year assignment questions, and also there will be some few additional questions that we will try to solve, and that will help you all to solve the assignment question as well as in the exam. So, but since this is the very first class, so I request you
Hello?
all. Yes. So I thought some was telling something. Janapati Anka Babu, I think you have raised your hand. So, do you have any doubt? Okay, so I'm lowering your hand. I think only one hand is raised. So, am I audible? Is there any problem with the audio and video?
No, madam, you are audible.
Okay. Okay, thank you. So I think I should wait for a couple of more minutes because a few people are still joining and it is interrupting in between. So I have to give access every time if someone is joining. So let's wait for 2 more minutes. Or rather, we can start with the brief introduction about yourself, like what is your name and from which place you belong, or you are a student, or from which college you belong, if you are from some company, or from some, if you are some lecturer or something like that. So, just a small brief introduction from each of the participant, and then we will start. So, can I request, please, any one of you can start?
Yes, ma'am.
Yeah.
I am Sagar Shinde, working as assistant professor in Walchand College of Engineering, Sangli.
Okay. Thank you, Sagar. So, can we
Thank you,
have?
ma'am.
Okay, thank you so much.
Good evening, ma'am.
Good evening. So, I
Myself,
can't.
L.R. Shardhan, ma'am.
Yes.
I am a student from Beltech University, third year CSC student, ma'am.
Okay, third year?
CSC branch.
Okay, okay.
Thank you, ma'am.
Okay, thank you. So, others, please.
Good evening.
Good evening.
I am Harsha, studying physics from Manipur Sundarnar University, ma'am.
So, you are a student?
Second MSc physics, ma'am.
Second year MSc student.
Yes, ma'am.
Okay, okay, thank you.
Thank you, ma'am.
Others, please. So, okay, let's. So, I will take one by one name of yours. So, can I request Pooja to please unmute yourself and give a brief introduction about yourself, like from where you belong, whether you're a student or something. Okay, I think Pooja is not available. P. Priya Varsha.
Good afternoon, ma'am.
Good evening.
Um, my name is Priya Varsha. I am from Weltech University, third year CSC department.
Okay. So, what is the
Thank
full
you.
form of this CAC?
Computer Science and Engineering.
So, but this course is municipal solid waste. Is it compulsory from your college or you're taking is just like an additional
Um,
course of your own?
it is an open elective, ma'am. We have to take
Open
from
elective.
different department other than CSC. We
Okay,
should
okay,
take from
okay.
different.
Okay, okay, okay. I got it. Okay. I think there are more three students from Weltech University. So, 5 more minutes. If any one of you want to give an introduction about yourself, because there are many participants, taking introduction of each of one of you will take time. Any five of you? Okay. Okay, let's start then. So just let me share my screen first. So is my screen visible?
Yes, madam.
Okay. So welcome to the problem solving session for the just wait a minute, I'm getting disappearance. Next time I will change the setting because every time I have to admit that participant. Okay, let's start. So good evening everyone. Welcome to the first problem solving session for the course Municipal Solid Waste Management, and the course instructor is Professor Ajay from Department of Civil Engineering IIT Guwahati. and I am one of the TA for this course. My name is Asma Parveen, and I am a PhD scholar in Civil Engineering Department at IIT Kanpur. So I'll be your TA for one of the TA for this course. I'll be taking weekly sessions on every Saturday from 6 to 8 p.m. Here we will discuss about the previous year assignment questions, and also we'll discuss some of the theory along with some additional questions. So just give me a minute. There is more participants. Okay. So first we'll see the lecture materials. So let me go to the first lecture of this module 1. So this is the very first lecture of module 1. What is solid waste? So waste can be in the any form. It can be gaseous or it can be waste. What in the form of liquid or it can be solid. If it is liquid, we generally consider it as waste water. Air, if it is in air, then we consider it as air pollution, air pollutants, and if it is in the form of solid, then we call it as solid waste. And if that solid waste is coming from some municipality, then we call it as municipal solid waste. So any waste that arises from various human and animal activities, and some material which is discarded as useless or unwanted by the owner, then it is considered as waste. And one of the very problem of the solid waste is it is very heterogeneous in composition. Like if we see wastewater and if we see the water from the sewage treatment plant which come from the municipalities, it is somewhat homogeneous. If you mix the wastewater, it will become homogeneous. But for solid waste, it is very heterogeneous. It consists of plastic, paper, cardboard. It can consist of food waste and litter from the institutes and many more. So the composition of solid waste is heterogeneous, and that's why for management of solid waste, it is very, very important that we segregate all the components of the solid waste and then recycling and reuse can be done. So some of the commonly used synonyms for solid waste. So some of the synonyms, words which are used for solid waste are like refuse, garbage, rubbish, scrap, debris, and these have different significance. Like scrap is the waste that has high metal content, rubbish is the waste with very high ash content, debris is bulky waste from the construction waste, and so on. So this is the material flow for the waste generation. So here we can then see that from the raw material processing, some waste is generated, and that raw material goes in manufacturing, and also there is also waste is generated. Then from secondary manufacturing, some waste is generated. It goes to the consumers, and from the consumers, it goes finally to the disposal. And from here, from disposal, it can be processed, and some of the materials can be processed and recovered, and it can go from this vessel cycle will follow. It will again go for manufacturing and then again it will give some of the waste, and it will goes to consumers and finally for disposal. So here it is, example is given for coffee beans. Like coffee beans are first roasted, and the roasted beans are made in coffee powder, and it goes to consumer, and from the consumer, the coffee bottles and all goes for disposal. And during the processing of the coffee beans, some of the waste are generated, which can and which like the coffee shafts are used to produce headlight cover used in car parts. So this is the reuse or recycle of the byproduct from the coffee. So why solid waste is a consequence for life? So here we can see in the pictures also that the first picture is about a dog eating from the garbage which is dumps along the side of the road. So here this scene we can see on majority of the roads, like where garbage is littered around the road. This is the improper landfilling of the solid waste which generate lot of water pollution from the leachate. So a lot of water pollution is generated from the leachate, and it also pollutes the groundwater as well as with the surface water. Here we can also see lot of birds are attracted, lot of birds and rodents are attracted for because for in these landfill, and that cause lot of pollution as well as lot of diseases. And here we can see that the picture of smoke coming from the landfill because of the improper management of the waste which is dumped. Because of the anaerobic degradation of the waste, methane is produced, and methane is highly it catches fire very fastly. Because of that, especially during the summer season, these landfill catches fire and lot of smoke comes out from the landfill. So here
Hello, ma'am.
yes.
Madam, well,
Sorry.
screen is not visible, ma'am.
Oh, I'm so sorry. Okay, think there is some problem. Is the screen visible now?
Uh, no, ma'am.
No. Okay. I think now the screen is visible.
No, ma'am.
Okay.
No, ma'am.
Yes, ma'am.
Visible, ma'am.
It was visible now because I had already shared my screen. So is it visible now?
Yes, ma'am.
Yes, ma'am.
Okay. Okay, thank you. So I was telling about the improper handling of the solid waste, which is dumped unscientifically, or I should say in unengineered ways in the landfill, which cause lot of pollution and problem. The public health and the management of the solid waste is very much related, and the consequences of improper disposal of solid waste can be very problematic. We can see from these pictures. So these are the second and the third picture is for the improper landfilling of the solid waste. In the second picture, it is causing water pollution, and the third, there is smoke coming from the heaps of the waste which is dumped in the landfill. And this picture is from the Kolkata's permanently burning landfill. And the first picture is for the waste which is dumped along the side of the road. So let's move. So here we can see this that the solid waste or the plastics and nets which are used for fishing and all, it causes lot of damage to the aquatic ecosystem. Here we can see a turtle which is very badly messed up in the net which is used. Here we can see the pictures where the and aquatic animals are dead on the beaches. Here we can see pile of plastic waste which is floating on the ocean. So management of solid waste is very very important because it is very much related to the if it is improperly managed, it will cause water pollution, it causes air pollution, it affects the aquatic ecosystem, it affects the human health, and it even affects the terrestrial animals. So management of solid waste is very important. And with the increase in income of any country, the amount of solid waste which is generated with it increases because there is a direct relation between the amount of income of the person and how much solid waste or that person is generating. And especially with the new technologies of the like packed food and canned foods, the generation of solid waste has increased. So these are the some of the examples in how solid waste has affected in recent years. So there was a cloudburst in Mumbai in 2005, which clogged the sewer lines due to large number of plastic bags. These bags choked the sewer lines, and there was a lot of problem. Next is the example from Chennai, and next is from Bhushan Steel Factory at Noida, which is was there was a blast due to imported scrap from Iran. And there is also reduction in number of migratory birds due to consumption of contaminated food from these landfills. In fact, the stray animals like cows, they eat the plastic and it is very harmful for their health. And in fact, some of the cows die because of eating of the plastic waste from the roads. And also recently we have everyone would have heard about the news for the catching of fire in the landfills in Delhi and various places. So here is a scheme where the management of municipal solid waste was very much practiced from very old time in our country. There was Vedas which says that we should live in harmony with the nature. Humans and nature, these are interconnected, and humans should live in harmony with the harmony in the with nature and should not cause pollution in the surroundings. So here, some of the schemes are given for management of municipal solid waste in New India, like Swachh Bharat Mission, which was starting in 2014 from there segregation and waste collection of waste with segregation was started, and there was also there is the rules for municipal solid waste management. And the recent one is 2000 Municipal Solid Waste Management Rules 2016. So this is the end of the first lecture. Let's go to the second one. I think the second one was sources and types. Yes, this is the second one. Sources, types, and characteristics of solid waste. Sorry, this is the third one. Yes, functional elements is the second one. So here we'll discuss about what are the functional elements of solid waste management. I think this is not the second one. Okay, this is the second lecture of module 1, functional elements of solid waste management. So here we can see a picture where the waste is first generated from any household, and there a primary collection is done, and in fact in the household the waste is stored for a day or depending upon the frequency of how or in how many days the waste is collected. And after the primary collection the waste is handled and stored, and from there it goes to the secondary collection, and from the secondary collection waste is either processed and transformed, and the remaining waste is sent for disposal, or directly from the secondary collection waste can go for disposal without any processing, and from the secondary collection the waste is transferred or transported, and finally it goes to disposal. So, the activities associated with management of solid waste from the point of generation to final disposal have been grouped into 6 functional elements. So, we will see each functional element one by one. First is the waste generation. So, any waste, any substance which is no longer for use for by any consumer or user is regarded as waste, and it is dumped by that user. And it is this one is the very first step for the waste generation. Next is waste handling and storage. These involve the activities associated with management of waste until they are placed in storage containers for collection. So the container can be two types, hall containers or stationary containers. So in hall containers, containers are taken from these sites to the final processing or transfer stations, and in the stationary stations, the containers are fixed, but the waste is transferred from these containers to the transport vehicles, and then that waste is taken to the transfer station or processing stations. So in next is the primary collection. So this third one is the primary collection. It includes gathering of waste and recyclable materials from the waste sources. So here we can see here the waste is gathered from all the households, or we can say from all waste from all the houses in the community is gathered at one place, and it is community level collection. Or and in recent we have door to door collection where kabadi walas they come, or the person with vehicles come, They collect the waste separately for biodegradable and recyclable waste separately, and they take the waste for further processing. Next is secondary collection. So it includes the operation of collection vehicles from dustbin areas to landfill disposal sites. So here we can see that the waste has been collected from the stationary containers and waste is directly taken for further processing. And here we can see in the second picture that the containers are hauled from their position, and these containers are taken, and the waste from these containers will be transferred at the transfer stations and can be further processed. So here the fourth step is processing and transformation of solid waste. So here we can see the picture where the plastic waste is getting segregated or processed, and here we can see the piles of compost from the biodegradable material which is getting processed for making compost. And this step of processing and transformation of solid waste is very, very important because this is the step where all the reusables can be recycled and reused, and the remaining waste, which is of no use, that can be sent for further processing. And this step is very important because it collects all the resources from the waste and it is reused. Next is the transfer and transport. So it has two steps: transfer of waste from the smaller container vehicle to the larger transport equipment, and subsequent transport of the waste to the disposal site. So the waste from the smaller containers are transferred to the bigger containers in the vehicles, and these are transported to the final disposal site. So finally, last step is the disposal. Here we can see a picture of the landfill where a lot of animals and birds are on these landfill, and this is very unhygienic and unengineered way of disposal of waste. And in India, majority of the waste goes finally to the landfill without any processing. So here it is a picture of an engineered landfill. So very first layer is first layer is made which where some plastic or specially designed materials are used to separate the separate the groundwater and percolation of the leachate from these landfill, because as we know, with time these waste will degrade and it will produce wastewater, which is called as leachate. And also during degradation, since it is compacted, there is no air inside, so in the lower layers anaerobic degradation takes place, which causes methane from the biodegradable materials. And for that also uh, there is pipes and all to collect the gas coming out from these waste piles. And there is proper in an engineered landfill, there is proper management of the leachate as well as the methane gas which is produced, and in fact from this methane gas energy is produced. So if there is a landfill like this, then the groundwater below the landfill is also not contaminated from the leachate, and also surface water, surface ground soil, and in fact the air is not contaminated if there is proper management of the solid waste. So let's move to the third lecture, that is sources and types of solid waste. So there can be three types of solid waste we can broadly classify. First is the municipal waste, which include the waste like food waste, ashes, residue, construction and demolition waste. These all come from municipalities. Next, we can divide it into industrial waste, which come from the industries like the steel industry, or it can come from paper industry or thermal power plants. So these are the industrial waste. Next is the hazardous waste. So these are the waste which are very harmful for human as well as for the environment. And for hazardous waste, there is different rules in India. There is hazardous waste management rules, and these waste are handled according to those rules. So one of the waste is the waste coming from the hospitals, because it can contain lot of pathogens and viruses, and it can be very, very harmful for the humans and the environment. So here, the waste coming from any municipality, it can be regarded as municipal waste. Waste from the industries are called as industrial waste, and the solid waste from bio waste, hospital waste, it is regarded as hazardous waste. So on the basis of source, it was like if the on the basis of source of generation from where the waste is generated, it can be classified as residential waste. So these waste are generated from household activities, like, and it consists of like leftover food, plastic, papers, clothes, cardboards, and etc. Next can be commercial waste, which is generated in offices, commercial buildings, restaurants, hotels, warehouses, markets, etc. And the third one is the institutional waste, which comes from the institutes, and these are generally generated from educational, administrative, and public buildings such as schools, colleges, offices, etc. And it mainly consists of paper, plastic, glasses. If it is coming from some institute, then it will consist of lot of electronic waste, a lot of paper waste, and so on. So here we can see like municipal waste include waste resulting from municipal functions and services such as such as street waste, road sweeping, dead animals, and abandoned vehicles. These all comes under the municipal waste. And industrial waste consists of discarded material of manufacturing and processing in industrial operation. It can be wet or dry depending on the operation. So like if the paper, it is coming from paper industry, so it will have papers. And if it is coming from some thermal power plant, then it will have lot of ash because of burning of the coal, and so on. So here the picture is given for construction and demolition waste. These come from the construction sites because of the repair or construction of some new buildings, houses, or other structure like bridges, and they mainly consist of concrete, wood, or steel, and lot of dirt. Next is the agriculture waste. It comes from the agriculture fields, and it consists of the leftover parts of the harvested crops. And also if there is some crop, then some part of that plant is used, and the rest is litter, or we can say that rest is the waste. So it comes from the agriculture remains generated from the field, orchards, vineyards, farms, etc. So this was the third module where we have seen sources of the waste and classification of the waste. So based on the basis of the source, we can classify the waste, and generally we will discuss about municipal solid waste management in this course. So let's move to the fourth lecture, which is sampling and characteristics. So sampling of municipal solid waste has also some protocols. It is mainly a lot of waste is collected, and the sampling is done for all the 4 seasons, and it is done twice a season, and the sampling is done for whole week. So this is done because the solid waste is very heterogeneous, and if something is heterogeneous, then we need to collect large amount of waste so that we can get better insight into its characteristic. So basically, so if 100 kg of the waste is taken, then it is divided into 4 parts. The method is known as quartering method. And from that 4 parts, two part is taken. That will be around 50 kg. It is then further divided into 4 parts, and that half of the waste will be taken, and it will be further divided into the 4 parts. And if you like, it is 6.25 and 6.25, so it will be very nearly 10 to 12 kg of the sample. For chemical analysis, it will be dried, grinded, and sieved to get is more homogeneous mixture. And the physical analysis is done in the unprocessed waste. So this is a method for sampling of the solid waste. So the waste will have any material will have three types of characteristic. First is the physical characteristic, chemical characteristic, and finally biological characteristic. So in the physical characteristic, the waste are separated on the basis of physical properties such as dry, wet, paper, glass, metal. So this is the various categories of the waste. So on the composition analysis, each type of waste will be segregated and separated differently. And they are weighted, and each fraction is each component of the waste. Like if it is dry waste, then it is separated and that is weighted, and it represent a fraction of the total waste. So the uh, compositional analysis is very important because it helps to for the selection and operation of the equipments and facilities that will be required for processing of the waste, and also it helps in design of the disposal facility. So here we can see CPCB, that is Central Pollution Control Board report for the municipal solid waste characteristic of few cities in India. So this report is from 2000, year 2000, and here we can see that the inner material was concentration per fraction was very high in all the cities. It was nearly 50% in Ahmedabad. Um, in Delhi, it was around 51%. It was 50% in Hyderabad. So inner fraction was very high, and here we can see that the percentage paper is quite low. But here we can see that the biodegradable matter is very high. It is nearly between 40 to 50% in almost all the cities except for Delhi. It has lower Delhi and Coimbatore. It has lower biodegradable fraction. So here we can see for different other cities, here the same trend is followed. Like biodegradable matter is high, inert materials is high, and the reusable or recyclable like paper, textile, plastic, glass, metals is low. And also here we can see that the percentage of the plastic waste is very less. It is nearly between 1 to 10%. And in the previous table also, the fraction of plastic waste is very low for the year 2000. So the compositional variation. So the variation in composition depends on three factors. First is the location, next is season, and third is the economy. So location is like if it is a hilly area, plain area, or it is a warm area or a cold area. So generally in hilly areas, less waste is generated. And season is also a factor for determining the composition of the waste. Next is the economy. So generally in economy, the higher income group household, they generate more fraction of dry waste as compared to lower income group households, because in higher income households there is a tendency to purchase everything in packages, so so there will be a lot of dry waste, and and there will be lesser fractions of wet waste. But in lower income households, the majority of the income goes in purchasing of the food and other materials, and they generally prefer unpacked materials because they are comparatively cheaper. So that's why in lower income groups households, the majority fraction of the waste which comes out is wet waste, and generally, and majority of it is biodegradable waste, that is food waste. So here we can see the compositional variation of municipal solid waste in India. So the blue one is for the biodegradable material, and we can see that the fraction of biodegradable material is very high in India. It is more than 40% from 1996 to 2011. And for the inert material, we can see that the fraction of inert material has decreased a lot. But here we can see that there is increase in the amount of plastic and rubbers which is coming out from the household. So in 1996, it was very low. It was 0.6% of the total waste generated, but in 2005, it was 9.22%, and in 2011, it is more than 10%. So we can see that there is an increased tendency of use of the plastic materials, which has increased the generation of the plastic and rubber waste. So let's move to the next slide. So the next property, physical parameter, is a specific weight. It is defined as the weight of a material per unit volume. So density or specific weight is very high in India for the solid waste generated because of the inert material and because of the food waste which is there in the waste. Because here we can see that the food waste is a very high density, and inert material like ash or dirt, these also have very high density. So because of that, the density of the overall waste which is generated in India is very high. And specific weight is very important because it helps to determine the capacity of the vehicles which will carry the waste to the landfill, because based on the density of the waste, compaction can be done. If the density is less, then more compaction of the waste can be done. But if the density is already very high, then more compaction of waste cannot be done. And if we compare a developed and developing nation waste, so developed nation waste have a higher compaction capacity because there the fraction of food waste is lesser, but the fraction of plastic and paper and glass waste, sorry, not glass, paper waste is very high. And these are and also there is lot of cans which are generated. So they, since their density is low, so the overall density of the waste is lesser in developed countries as compared to the developing nations. Next is the particle size. So the particle of size of the waste is determined based upon its length, width, and height, and these are the formulas which are used to find out the size of the waste components. And these are important in consideration in the recovery of the materials, especially where mechanical means such as trommel screen and magnetic separator are installed for recovery of the metal waste. So here we can see a trommel screen. So these are the figures for the trommel screen. So here the waste is fed from here, and these have screen drums. So from the screen drums, the smaller size waste goes out, and the larger size waste are they're in the drum itself, and through this the waste is segregated based on the particle size. So here it is a magnetic separator. These magnetic separator are used to separate the iron waste materials. So here these are the magnets which attract the iron particles, and these are removed from the remaining waste. Next physical property is the field capacity. It is the total amount of moisture which can be retained in the waste with the effect of downpull gravity of the waste. If field capacity is that much amount of moisture which the waste can hold in it without the leaching of the water from it. So it is very important in determining the how much leachate will be generated in the landfill, and any water which is in excess of the field capacity will be released, and it is called as leachate. So next are the chemical characteristics. So first one is the proximate analysis. So in proximate analysis we determine three things, four things: moisture content, ash, volatile, and fixed carbon. So first one is the moisture content, which is determined at 104 degrees centigrade by drying the sample for 24 hours. And next is the ash content, which is generally determined at 550 degrees centigrade by after combusting the waste at 550 for 2 hours in an open crucible, because the crucible should be open for combustion of the waste in presence of oxygen. Next is the volatile matter. It is generally determined in the range of 700 to 950 degrees centigrade based on the type of the waste. And this is the portion of the waste that is converted to gas before and during combustion. Next is the fixed carbon. Anything uh, uh, Fixed carbon are the residue left after volatile matter is removed and it is combustible. So if you find a moisture content, ash content, and volatile, and if you subtract these from 100, we will get the fixed carbon content. So here it is an example of a proximate analysis of municipal solid waste of Jalandhar city is given. So Here we can see that percentage of moisture content, volatile matter, ash content and fixed carbon content is given, and along with the calorific value is given. Here again for Bhopal is given. So here we can see that volatile matter fraction is very high and moisture and the others are low. Next is the ultimate analysis. So in ultimate analysis, CHNSO is done, which is carbon, hydrogen, oxygen, nitrogen, and sulfur is done. And it is useful during mass balance calculation for chemical and thermal processes. Also, C by N ratio is very important for biological conversion process. So there is some fixed carbon to nitrogen ratios for biological processes to take place. And in ultimate analysis, we determine both carbon and nitrogen, and it is very and from here we can find out the whether this waste can be degraded by microbes or no. And the CHNS analysis is generally done in CHNOS analyzers. So again here an example for CHNS for both Jalandhar and Bhopal city is given. Next is the calorific value, which is determined in calorimeter. So this is the formula to find out the energy content in BTU per LB. So if there, don't think there is numerical in the very first week. So if there will be further numericals, we will discuss this formula there. So basically, for energy content, calorific value bomb calorimeters are used in which the sample is burned and various parameters like how much heat is generated. All these are find out, and based on that, calorific value is determined. So here the calorific value and moisture content of municipal solid waste for Indian cities are given, and this is from the NEEDI 2006 report, and maximum, mean, and minimum values are given. So here the net calorific values for different fractions of waste are given. For like paper and cardboard has very high calorific value, and plastic has very highest calorific value because of the lot of organic carbon content in it. That's why it has very high calorific value. Next is the metal contains. So the trace metal contains like cadmium, lead, and like metals like cadmium. They do not have any. They are non-essential metal for humans, plants. That's why if they are present in so if they are present in higher concentration, then that can be very harmful for the environment and from the human and plant health. That's why determination of these trace metal content is very important, and it is done by instruments like AS, that is atomic absorption spectroscopy, or it can be done with ICPMS, or it can be done with MPAS or ICPOES. So there are various instruments available for determining the metal content in the waste. So next characterization is for the biological. We have discussed about physical and chemical properties. Next is the biological. So the most important so the most important biological characteristic of organic fraction is of organic component can be converted biologically to gases and relatively inert organic and inorganic solids. So volatile solids are often the measurement of biodegradability of the organic fraction of the solid waste. So if there will be very high content in the waste, then it can be highly biodegradable, but there is not direct correlation, because here we can see the example which is given from the for the printed newspaper. Like they have very high volatility, but they have lower biodegradability because of the lot of chemicals are used for printing. So we can find out the lignin content of the waste, and it can be used to estimate the biodegradable fraction. So there here it is a formula is given, like biological fraction is 0.83 minus 0.028 LC. And these 0.83 and 0.03 are empirical constant, and LC is the lignin content, and there is a proper protocol to find out the lignin content of the waste. So here also by a percentage of biodegradability of the each waste is given. Like waste like metals, they are non-biodegradable. That's why it is given as 0. For glass also it is 0. And for food waste, it is 0.2. So it denotes that it is highly biodegradable. Next problem we can face is of breeding of flies. So if there is a waste which is dumped along the side of the road, or if it is on the landfill, then they attract a lot of flies, and flies can mature in less than 2 weeks, and that can be very problematic. So it is very important to store the waste properly before disposal. Next problem can be of the odor. So and because of the decomposition of the waste, if a lot of H2S can be generated, and that has very pungent smell, so it can cause lot of odor. So this modern lecture was about the characteristics of the waste. Sorry. So let's move to the next module. So next is about estimation of solid waste quantity. Sorry for the disturbance. Next is about importance of waste quantification. So how much quantity of solid waste is generated and collected? It is of very important because the central processing facility, the dumping sites like landfill, these are designed based on these, and all the equipments which are used during the processing are also designed based upon how much waste is generated. So in designing, we will see the waste collection routes, municipal recovery centers or facilities, and the disposal facilities. All these are designed based upon amount of the waste which is generated. So here different trends for municipal solid waste is given, and how much fraction of recyclables are given. So here we can see that very less amount of waste is recycled in India. It is nearly 20%, and also based on the different parts of the country, we can see that majority, that is 21.44% is recycled in West India, and the fraction is very less in South India. So the designing of solid waste management facilities are done based on the how much and what type of waste is generated. And the municipal solid waste generation estimation, it leads to the evaluation of the collection efficiency and treatment efficiency. So here we can see that for different states, how much municipal solid waste was collected and how much was treated. It is given for different states. Next is quantification of the solid waste. Next is in quantification, we can do the quantification of the waste in the base of volume or weight basis. But volume will change if the waste is compacted. So weight is better. It is better to weigh the waste and find out the how much kg or tons of waste is generated, because it will not change, but the volume it will change if the waste is compacted. And so that amount, how much tons of waste will be is generated, that will be used to find out the capacity of the collection vehicles and all. So here there is some data which shows the measurement of municipal solid waste quantification in India. So here it is given for different states. So here we can see in the Maharashtra there is the highest generation of the MSW, and for different states it is different. So it is from the CPCB report from 2000, and again here some data showing future prediction of municipal solid waste quantification in India. So with time, the generation of municipal solid waste is increasing, and also there is a graph I will show in the next lecture, which shows that in developing countries, the generation of the municipal solid waste increases, and after some point it reaches saturation, and again it starts to decline because if the countries goes towards development, and finally when it becomes developed countries, so the recycling facilities gets more organized, because in India we have unorganized sector for handling of the solid waste which is generated. Which we have generally the kabadi walas, which comes and collects the waste and they sell, and then they sell and get their income. But in developed countries, there is proper sectors for management of these solid waste. So that's why they have very high. That's why the municipal solid waste generation increases. At the same time, the municipal solid waste treatment and processing increases. So that's why the final amount of the waste which goes to the landfill, that decreases with as the country goes from developing to developed nation. So I will show that graph in the next problem solving session. So here various expressions which are used for the solid waste generation. Like for residential waste, it is generally calculated in terms of kg per capita per day. How much amount of waste is generated in one day. For commercial waste also, it is calculated as kg per capita per day. For industrial, it is waste. It is calculated in the terms of kg per product. Like for one product, how much kg of the waste is generated, and for agriculture waste is calculated in the forms of kg per raw product. And here our table is given for solid waste generation of some Asian countries in kg per capita per day. So in India, we have the generation on the basis of the city. If it is a large city, then we have nearly 0.5 kg per capita per day of waste generation. If it is a medium city, then it is 0.3 to 0.4. And if it is a small city, then it is nearly 0.1 kg per person. Capita is how much a person is generating in that city divided per day. So here we can see that Korea, it is a developed nation. Here, the solid waste generation per capita is very high as compared to India. For China, it is very high. It is comparatively higher than India, and for Hong Kong, it is also very high. So in developed nations, the municipal solid waste generation is very high per capita basis. So here, the per capita per municipal solid waste generation of different cities in India is given. So here we can see that on the left side, these cities are small cities. So here the municipal solid waste generation is less than 0.1 kg per capita per day. And for larger cities like Chennai, Kolkata, Delhi, and Mumbai, it is more than 2 kg per capita per day. So the method which are used to estimate the waste quantities are load count analysis or weight volume analysis. So in the load count analysis, the number of individual loads and the corresponding waste characteristics are noted over a specific time period. So how many individual loads and what are the characteristics of the waste which is being carried by that vehicle is noted, and from there the estimation of the waste is done. And in the weight volume analysis, collection vehicles are these vehicles are weighed at the entrance of the transfer stations using some weighing mechanism, and that weight the empty weight of the truck is known, and the final weight along with the waste is weighted, and finally how much waste is being generated is find out. So here we can see a platform which is used to find out the weight of the each truck entering this in this facility. And here a figure is given where we can see that the weight of the collection vehicle is taken at the entrance of the transfer station. So the material mass balance analysis can be done for the municipal solid waste, and the general mass balance, which is accumulation, is how much inflow is there minus how much is going out plus generation. It will generation, or there should be degradation also. So if we take a stored material, so there will be some waste will be coming inside, some will be combusted gas and acids that will be going outside, and the finally the solid waste which will be remaining, that will be the outflow. And also, if the waste is processed, then there will be some products coming out from that facility, so that will also comes in the out. So here a mass balance for landfill is given, like waste place, it will be the overall of mass leaving through leachate. How much is mass is leaving through landfill gas, what waste is remaining, and the mass transformed to other products. So there is a lot of transformation of the waste, like a lot of reactions is taking place. Also the size of the waste changes over time. So all these are taking into consideration, and like this the mass balance can be done. So this was the fifth lecture. So let's move to the sixth one. So the sixth one is the factors affecting solid waste generation rate. So waste collection rates. So the collected include waste in communities without recycling program, or there can be source separated waste in communities with recycling program. So, so there can be some communities where there are the rag pickers which comes, they collect the things which can be recyclable, and also there can be different containers to store different type of waste. So like this, the waste can be separated. So it is known as source separated waste, and finally it can be collected. Or in commingled waste, all the waste materials are mixed, and it is very and the segregation of the waste is done in the recycling waste processing facilities, and it is very difficult to separate all the waste. So here the collection efficiency of a few countries in India is given between year 2010 and 15, and here you can see that there is generally increase in the trend of for increase in the collection efficiency for different cities because of the Swachh Bharat mission. So here in the Swachh Bharat mission, after there is source segregation of the waste, so like waste is um, uh, food waste or biodegradable wet waste is collected differently, and dry waste is collected separately. So again here where a graph is given which shows variation is in collection efficiencies of different states in our country. So here we can see that Kerala has very less collection efficiency, but we can see highest collection efficiency of nearly 100% in Maharashtra. Again, graphs here a graph is given for it is given for European countries. So here also we can see that there is some gap between how much waste is generated and lesser amount is collected. So the factors which affect the waste generation rates are effect of source reduction on waste generation. So if there will be source reduction, like if there is shift from the paper bags to the long-term use plates and other products, so there will be reduction in the overall amount of the waste which is generated. So there can be products with higher durability. There can be shift from plastic bags to the cloth bags. There can be shifting from printing print photocopying from one side to both side, use of reusable pads and napkins. So these all can lead to lesser waste generation. So the effect of recycling activities on waste generation. So if the dry waste and wet waste is separated, the wet waste can be composted to make compost. The dry waste, it can be further segregated in glass, plastic, metals, and then it can be further processed and recycled. And because of recycling, and the overall waste generated will be reduced. So here some facts and figures for different for our country is given. So here we can see the data for 2014 to 15. The collection efficiency was very high, but only 73% of the waste is sorry, 27% of the waste is processed, and 73% of the waste is directly going to the landfill. And as we know, the land for acquiring of the landfill, there is lot of dispute. First, the land is costly, and next is the area surrounding the landfill. The people do not want the landfill to be near their houses because it causes lot of pollution, and it attracts lot of animals, birds, and yeah, there is lot of odor problem from these landfills. So the processing of waste is very important. So here some facts are given for USA. Here we can see that the percentage of paper and paper board are very high. Sorry, these percentages are given for recycling, and we can see that with time the recycling percentage has increased. It is nearly 66% for paper and paper boards in 2017, and also for all the types of waste we can see that the percentage of recycling has increased in for different categories in USA. And in US, the overall recycling rate was nearly 35% in 2017, but in India it is lesser. It is nearly 27%. Next is effect of public attitude and legislation on waste generation. If the public will be um, aware about, like, if someone is aware that they should not use plastic, rather they should use they should use cloth bags, jute bags, then also that will reduce the waste generation. And there is lot of legislation and lot of bans in also in our country for not using the plastic bags. So the legislation also plays role in generation of the waste. Next is encouraging the purchase and use of the recycled materials. So this is generally done in our country by kabadi walas, or I should say rack pickers. They come, they purchase the used papers, cardboards, metals, and through this, the overall waste generation and that is generated reduces. Next is the effect of geological and physical factors. So these factors also affect, like in hilly areas, there is lesser production of waste, and then plain areas, and also there is a variation of the season. So during summer, there is lot of production of waste as compared to winter seasons. Also, the collection frequency also has a lot of effect on the generation of the waste. So in areas, more waste is generated in areas with unlimited collection services. So if the collection services are limited, then that person or that community will generate lesser waste because they have to store that waste in their household or in their community or in their locality. So it also affects the waste generation. So characteristics of the service area. So higher income group will generate more waste as compared to the lower income group. And here we can see that income capacity is directly proportional to the waste generation. So if the with increase in income of the person or community, there is shift towards the use of the packed food materials and everything they purchase in packed packed packages, and this lead to generation of lot of waste. But if you go to lower income groups, so majority of their income goes towards purchasing of food for their families. So they do not purchase lot of packages So that's why the generation of waste is lesser in low income groups as compared to higher income groups. So I think this was the last lecture for week 1. So week 1 is mainly about uh, what is waste, classification of waste, characterization of waste, and generation of waste. So all these was covered in week 1 lectures. So now we will move to the few questions. That is, these are the previous year questions based on week 1. So in this problem solving session, there won't be any numerical, but hopefully from next week we will try to solve few numericals based on these topics. So let's directly move to the questions. Let me share my screen once. I hope my screen is visible. If not, please, any of you can confirm me if it is visible or not. So
Yes,
can
ma'am, it is visible.
okay. Okay. So let's move to the first question. So the first question is, municipal solid waste include A, residential, institutional and commercial waste, B, institutional, industrial and commercial waste, or C, construction and demolition, biomedical or industrial waste, or D, e-waste, that is electronic waste, biomedical and residential waste. So I will give you all 2 minutes. Just take your time, read the question, and write the correct answer in the chat box so that I can see what you all are. Okay, I cannot see. Okay. So just write the correct answer in the chat box, and I will. And after 2 minutes, I will see what answers you have written, because I have shared screen from only one system. That's why I cannot go to the chat box. So please take your time and write the correct answer in the chat. Okay. So let's see which is the correct answer. So yes, A is the correct answer. That municipal solid waste consists of residential, institutional, and commercial waste. So other waste it also consists of construction and demolition waste. But biomedical waste it comes under hazardous waste, and industrial waste has different category. E-waste has different. Electronic waste has different category. So residential, institutional, and commercial waste. This is the correct answer. So A is the correct answer, and majority of you, almost all of you, have written A. So let's move to the next question. So the question is correct order of solid waste management is A. Transportation, collection, treatment, disposal. B. Collection, treatment, transport, disposal. C. Collection, transportation, treatment, disposal. Or D. Transportation, treatment, collection, or disposal. So I'll give you all 3 minutes. Just take your time and write your correct answer in the chat box. So, the correct answer is C. The correct order for solid waste management is first it is collected, then it is transported to the treatment facility or disposal facility, then it is treated, and finally it is disposed. So C is the correct option. So let's move to the next question. So the third question is waste produced from kitchens are A. Biodegradable, non-biodegradable, inert or combustible. So I'll give you all 2 minutes. Just write your correct answer in the chat box. So the correct answer is A. The waste from kitchens are basically vegetable peels, the waste food, and these are all are biodegradable organic matter. So basically, the kitchen waste are mostly biodegradable. So the fourth question is, biogas is mainly composed of A, carbon dioxide and hydrogen, B, methane and carbon dioxide, C, hydrogen and nitrogen, or D, methane and hydrogen. So I'll give you all 2 minutes. Just take your time and write the correct answer in the chat box, and then we'll see which one is the correct one. So the correct answer is methane and carbon and dioxide. So the biogas mainly consists of methane and carbon dioxide. So B is the correct answer. So let's move to the next question. So the fifth question is, what to do with plastic waste? A, composting, B, recycling, C, disposal in dump yard, or D, underground storage. So please write the correct answer in chat box, and then we will see which is the correct option. So B is the correct answer, that plastic waste are non-biodegradable organic matter. So they should be recycled and it can be used again and again. So B is the correct answer. For composting, the waste material should be biodegradable, like the waste from kitchen. These are mainly biodegradable organic matter. So these can be composted and the compost can be used in gardening. So plastic waste should not be disposed in dump yard because they clogs the soil, and it also harms the environment, human health. And with time, these plastic are not degraded in hundreds of years. With time, they are only the particle size of the plastic decreases, but the degradation of the plastic takes lot of time, so it should be recycled and it should not be stored underground because mainly the underground storage of hazardous waste is done. So the plastic waste should be recycled, and so for fifth, recycling is the correct answer. And the sixth question is technologies used for energy production. These are A, biomethanation and incineration, B, incineration and composting, C, composting and biomethanation, or D, composting and pyrolysis. So please write the correct answer in the chat box and then we will see which is the answer for this question. So someone has raised his hand. So please tell me what is your doubt. Sure, sure. So this session, in fact, all the sessions are will be recorded, and these video recordings along with the PPT which I am using, these will be uploaded on the Google Drive, and from there will be a section on the NPTEL portal from where you can access the link for this video. So this video will be uploaded in YouTube. So there will be a link for that also, and there will be link for the PPT which will be uploaded in the Google Drive. So everything is recorded. You will have access to the lecture materials and the video, everything. So please do not worry. So hopefully I will upload the video by tomorrow morning. So you can go to the NPTEL portal, and there I think there will be section for something called TAs, or there will be some section for I will personally go and check on the NPTEL portal for this course and will let you know what is that section in which these link for these videos are there. So the correct answer for sixth question is A, biomethanation and incineration. So in biomethanation, uh, in in biomethanation, the organic materials are converted under anaerobic conditions by microbes into biogas, which is methane. And next is the incineration. In this, the waste The waste material is burned and it produces lot of heat, and this heat or energy can be used to generate electricity. So A is the correct answer. And other options in which B is incineration and composting. Compost is done to convert the organic fractions into compost. Some and these can be used as soil conditioners. D is composting and biomethanation. So again, this is not the correct answer. And the last one is composting and pyrolysis. Even though through pyrolysis some energy can be produced, because from pyrolysis we get three fractions. The waste material is pyrolyzed. We get the solid material, which is known as char, which is the residue, and we get some gaseous product, which is the syngas. It consists of carbon monoxide, carbon dioxide, methane, etc. And in the gaseous phase, or only if this gaseous phase is condensed, then we get the liquid product, which is the bio oil. So only A is the correct answer, in which we will get biogas through biomethanation, and we will get lot of heat or energy through incineration, which can be used to generate electricity. So correct answer is A. So these were the 6 questions. Let's move to the questions which are basically dedicated or based on the module 1 of these are based on the 6 lectures of the module 1. So the first question is, we have to match the correct answers. So the option we have to match garbage, rubbish, what is garbage, what is rubbish, what is scrap, and what is debris. And all these questions are from the, I think, lecture 1. So I'll give you all 2 minutes. Just write the answer in the chat box, and then we will see which one is the correct one. So the correct answer is D. Garbage is mainly from the kitchen waste. B, rubbish is it has very high ash content. Scrap is something which is higher metal content, and last is the debris. It consists of bulky waste such as the construction waste. So D is the correct answer. So I think all 1 or 2% has written C, otherwise everyone has written D. So D is the correct answer. So let's move to the next question. So the second question is, the rule currently in practice for municipal solid waste management in India is, so 4 rules are written. So these are the Municipal Solid Waste Management Rule 2000, 1987, 2020, or 2016. So we have to tell which is the currently practiced municipal solid waste management rule in India. So please everyone write your answer in the chat box, and then we will see which one is the correct one. So the correct answer for second is D. The rule which is being followed in India is the Municipal Solid Waste Management Rule 2016. So the third question is, what are the sampling methods for waste characterization? So we have seen this in the characterization of waste lecture. So A, proximate method, B, ultimate method, C, quartering method, or D, cluster method. So we have to write which is the correct answer. So please write your answers in the chat box. So C is the correct answer. The method which is used for sampling of waste, solid waste, is the quartering method, in which the whole waste is divided into four fractions of uh, equal weight. And from there, again, the waste, half of the fraction of the waste is taken. It is further divided into four parts. And again, half of the fraction of the waste is taken. And again, it is divided into four parts. So quartering method is the correct answer. And proximate and ultimate method, these are the methods for chemical characterization of the waste. And cluster method is not something which is related with the solid waste characterization. So let's move to the next question. So the fourth question is, what type of waste are not included in municipal solid waste? So here more than one option can be correct. So A is plastic and paper from school. B is sanitary napkin waste from household. C is road sweepings and dead animals. Or D, pulp and paper mill sludge from paper industry. So we have to find out what type of waste are not included in municipal solid waste. So again, please write your answer in the chat box and then we will see which one is the correct answer. Okay. So the correct option for 4 is B and D. So plastic and paper and from schools, these are included in the municipal solid waste, but the sanitary napkin waste from households are not included in the municipal solid waste. They are handled differently. They are either burned, so there are different. There are smaller instruments for burning of these napkins. So these are not included in municipal solid waste. And D, pulp and paper meal sludge from paper industry. This, since it is coming from industry, so it is an industrial waste. So B and D are the correct option. So I can see uh, majority have you have written E as the correct answer. A is not the correct answer. C and D, no. B and D is the correct answer. Okay, let's move to the fifth question. Which of the following is not a component of physical waste characteristics? A, proximate analysis, B, specific weight, C, field capacity, or D, particle size. So here only one option is correct. So please write your answer in the chat box and then we will see which one is the correct. So the correct answer is A, proximate. Actually, it is not proximity analysis, it is proximate analysis. It is in proximate analysis, we find out the moisture content, volatile matter content, ash content, and the fixed carbon content, and all these comes under the chemical characterization. So A is the correct answer. Specific weight, field capacity, and particle size, all these comes under the physical waste characteristics. So here A is the correct answer. So let's move to the next question. So question number 6 is quantity of waste generated in high income group as compared to low income group will be A, more, less, same. It has no relation with income group. So this was also discussed in the lecture. So please write your answer in the chat box and then we will see which one is the correct answer. So A is the correct answer. The amount or quantity of waste generated in high income groups is comparatively higher as compared to the lower income groups. So the income is directly related to the waste generation. So if the income will be high, the waste generated will be high, and if the income is less, the waste generation will be less. So I think majority of you, I think every one of you have written the correct answer. A is the correct answer for sixth question. So next question is, which are the following elements are not measured in ultimate analysis? A hydrogen, B phosphorus, C carbon, or D nitrogen. So in ultimate analysis, we find out few elements. So out of these four, one is the one which is not measured in the ultimate analysis. So please write the option in the chat box and then we will see which one is the correct. So A is not the correct answer. In ultimate analysis, we determine C, H, N, S, and O. C, H, N, O, S, or SO. That is carbon, hydrogen, nitrogen, oxygen, and sulfur are determined in ultimate analysis. So phosphorus is not determined in ultimate analysis. So B is the correct answer. So for determination of phosphorus, the solid waste should be digested properly. It should be digested in acid, and then first it should be crushed, grinded, and sieved to a particular size, and then it needs to be digested in acid, and then finally the metal analysis, which either through AAS, that is atomic absorption spectroscopy, or from ICP-MS or MPAES. So all these instruments are used for metal determination. So through these instruments, phosphorus can be determined. Also, there are some method based on absorbance. So from by using the spectrometer also we can determine the phosphorus. But first, digestion of the waste is necessary. So B is the correct answer. So let's move to the next question. So the question is, after which initiative segregation of waste came into practice? So the various schemes are given. So the first one is Unnat Bharat Abhiyan, next is Swachh Bharat Abhiyan, C is Siksha Abhiyan, or D Waste Management Policy. So please write your answers in the chat box and then we will see which is the correct. Correct answer is B. After Swachh Bharat mission, segregation of waste at the source practice was started. So, for 8, B is the correct answer. And next question is 9. So, the question is, what is the temperature and time required for finding out the moisture content of solid waste? So, this question is based on the proximate analysis in which how to find out the moisture content of the waste was discussed. So there are 4 options. So the temperature is either 104 degrees centigrade or 105 degrees centigrade. So different times are given. So please write the correct write the option in the chat box, and then we will see which one is the correct. So the correct answer is B, and all of you have written B only. So that's good. So the temperature is 104 degrees centigrade and the time is 24 hours. So the moisture content is determined as 104 degrees centigrade by drying the sample for 24 hours. So B is the correct answer. So let's move to the next question. So this is the last question of week 1. So the question is, which of the parameters are not measured in proximate analysis? A. Ash content, B. Volatile content, C. In a fixed carbon content, or D. Calorific value. So we have to find out which of the following is not measured in proximate analysis. So please write your answer in the chat box, and then we will see which is the correct one. So D is the correct answer. Calorific value is determined to find the energy content of the waste, and ash, volatile and fixed matter. These are determined in the proximate analysis. So D is the correct answer. So these were the previous year question based on the week 1 module. So I hope these questions are clear to all. So if you have any doubt, then we can discuss. So if anyone of you have any doubt, just please unmute yourself and just and then we can discuss the doubt. Okay. I think there is someone has raised his hand. So just let me. So I think someone has raised a hand. Prashna, so do you have any doubt? Ma'am, tomorrow live class is going to teach this. Same. All the TAs will discuss the same previous year questions and the same lecture material. Maybe they will add some questions from their end. So that question will be different. Otherwise, the previous year questions will be same. Okay. Okay, then if there is no doubt, okay, thank you. So if there is no doubt, then I will end the today's problem solving session here. So thank you so much for joining, and please join the session on next Saturday from 6 to 8 p.m. So have a nice day. Okay, thank you.
Thank you, ma'am.
Okay, thank you.